Hey class, if you got this as a suggested video on the Unit 8 quiz, then it means you missed the expected value problem, which personally to me looks like the toughest problem on the entire quiz. It's very wordy, and it's got a lot of extra information that probably just on the surface makes it look so intimidating that some of y'all may have missed it just because it looked crazy. So I've come up with a similar question, changed a few things, but made it a very similar question over here on the left side of the screen. In a carnival game, when a player gives the dealer $5 for a bet on the magic number, the player has a 20/21 probability of losing $5 and a 1/21 probability of making a net gain. And then it gives you all this information about the prizes. Then it goes on to talk about another event. And if a player bets $5 on a red square, ultimately the questions are going to ask you to calculate expected value, and then to decide what's the best option, then you have to choose whatever option has the highest expected value, because in this case the expected value is money, and so therefore the higher the amount of money the player can win would make something the best option. So let's break it down. In part A, we are going to only want to focus on the magic number part. And here would be my suggestion. You can tell if you read it carefully that the player is paying $5 to play. It says gives the dealer $5 for a bet. So what I want you to do is just realize the player is either going to lose or win. And if the player loses the bet, then they just lose $5 because they paid $5 to play. So I'm just getting that from this first sentence. If they win, I read on and it says they get a net gain of $245 because the prize, it tells us, was worth $250, but minus the $5 bet that they paid to play. So, all that wording in the parentheses is just basically telling you that the number you want is 245. In other words, so many more words than you're really going to need to deal with. So that's what I would suggest, is putting down the losing amount of money and putting down the winning amount of money, which is the net gain. The other stuff you ignore. Then you need to put the probabilities right underneath. Well, it said the player had a 20/21 probability of losing the $5. So right under the -5, I'm putting that 20/21. And the probability of winning was 1/21. So 1/21. So that all I really have to do to calculate the expected value, which is what part A is asking about, is I'm going to take the value and multiply it by its probability. So multiply it by 20/21. Then add, because that's part of the expected value formula, the next amount of money times its probability. So 245 times 1/21. And all you really have to do is grab a calculator. Don't forget that this 5 is a negative right there. So -5, open parentheses, 20 divided by 21, close parentheses, and I'm literally typing it in my calculator just like this. Plus 245, open parentheses, 1/21, close. And I get $6.90. It's going to tell you to round to dollars and cents. Then for part B, I would do very similarly and go ahead, and it talks about now the red square. Well, the player is also betting $5. So if they lose on the red square, that's losing $5. But if they win, they get a net gain of 15. So net gain of 15. They really would win $20, but minus the 5 they paid to play. And again, all that's just that stuff in the parentheses. The probability of losing for the red square is 20/30. So you just have to go pick out this information. And the winning is 10/30. And you'll just do the same type of calculation. -5 times the 20/30 plus 15 times the 10/30. I'm putting it in my calculator just like I see it. Don't forget the 5 is negative. So negative 5 open parentheses, 20 over 30 plus 15 open parentheses, 10 slash 30. And I get 1.67 if I round correctly, $1.67. So those would be the answers that you put in the part A and B box. Make sure you round to dollars and cents. And in part C, the best option would be the one with the highest expected value. So in this case, playing the magic square would be the better option because it has a higher expected payout compared to playing the red square. So this was magic number, this was red square. Now, so that's how you do this question. Now let's suppose, because frequently when you're playing casino games and carnival games, you get negative expected values. So like, let's suppose that option A, I'm just going to kind of make up some hypothetical values. Let's suppose that option A had an expected value of, say, negative $1.25. And option B had an expected value of negative 0.75. Well, ultimately, B is better because since it's got negatives, that means you would lose the least amount of money. But here's the deal. If you look at the choices might say that playing the magic number is better, playing the red square is better, or not playing at all is better. If you get negative expected values for both game A and game B, then actually not playing is the better option because not playing would yield an expected value of 0. Obviously, if you're not going to play anything, you're not expected to lose or gain. So, if you get 2 negatives, your better option is just not to play at all. So you're going to have to base that part C answer depending on what answers you got for the part A and the part B. Totally depends on the, positive and negative signs and values and that kind of stuff. So hopefully that helped you realize that even though this problem looks so scary to start with, it really, honestly, if you break it down and just sort of do these charts that I showed you, is actually a doable problem and really hopefully not too tough. So give it another try.